Welcome everybody at today's talk in the Semantic Theory. We have a guest again from Austria this time. Claudia Wagner is visiting us, and she does really interesting research that appeals to me. I did a lot of research on ambiguity reduction in computations, and that's kind of like her topic too. She focuses on harvesting data from the web, but extracting meaning from it. Right? We can crawl data from online networks and the web in general. How do we assign meaning to the things we harvest? What do words mean? What do various communication patterns mean? She tries to include more characteristics of people that might influence the meaning of communication online. And I'm really curious what she has to say about that. She's going to be around for a couple of days, so if you have questions for Claudia or research, feel free to contact us or refer directly to us. She will publish your contact information for sure.
Okay. Yeah, so thanks for coming along. It's a great pleasure to be here. And the title of my talk today is Extracting Semantics from User-Generated Data. And the work I'm presenting was obviously done in collaboration with many other people, mainly people from my group in Graz University of Technology, but also with people from the Open University in the UK and with people from Sirius Park in California. So let me start by motivating a bit the research we are doing. So why do we need semantics in general? So semantics are useful for organizing information and for structuring information, and semantics are also required for making information on the web machine interpretable. And if I would show you, for example, this message, and I would ask you, what is this message about? I guess most of you could easily answer the question. This tweet is obviously about basketball. It's about a match between Houston and LA. And it's about a decision in the first round selection. And if I would show you a bit more information about the author of the tweet, you could probably also answer the question, what might this user know about? And for machines, it's pretty difficult to answer this question, since machines require semantic structures and semantic background knowledge in order to be able to interpret the meaning of the textual information. So semantics are obviously important to make information machine interpretable on the web. But why do we want to extract semantics from social media documents rather than from traditional media documents? Although we actually know that this information is often short and noisy, and that also the quality is questionable. Some reasons why we think that it makes sense to extract semantics from user-generated data is that user-generated content is growing fast, it's near real time, and there's almost no topic for which you can't find social media documents. But there are lots of topics out there for which we don't have peer-reviewed articles or things like that. And another thing which I think makes it interesting to extract semantics from user-generated content is that these documents are actually coupled with user behavior. So we have information about the behavior of users who are related with the document. And if one thinks about the process of creating meaning, the process of creating ontology, then it's actually as well a social process. Because an ontology is defined as a shared conceptualization of a domain of interest. And that means that a large group of users has to share a conceptualization, they have to agree on something. And that's obviously a social process. So far I've hopefully convinced you that semantics are important and that it makes sense to extract semantics from user-generated content. But I haven't explained what I mean by the term semantics. And since there are at least two groups of researchers working on semantics, and they mean different things by the word semantics, it's probably worth clarifying that. So there is this group of ontology engineering and knowledge representation people, and when they talk about semantics, they mainly talk about propositional semantics. So they believe in precise formal models of the world, so they are creating these models manually, and the models are powerful, but of course the creation and the maintenance of the models is expensive and time consuming. And then there is this other community, the data mining community or ontology learning people, and they basically believe in big data and in learning lightweight semantic models from data. And the advantage is, of course, that you can that the creation of these models is cheap, but they are less precise and less formal. So our work mainly belongs to the second camp of research, and when I talk about semantics, I mainly refer to distributional semantics rather than propositional semantics. So I have structured my talk today into three main parts. So in the first part, we will look into learning distributional semantics from public conversations on social media applications. So we will look whether lightweight semantics emerge from these public conversations and whether social factors impact these emerging semantics. In the second part, we will look into learning semantic user profiles from public conversations. So we will try to create expertise profiles of users by observing their activities on social media applications, and we will look into whether different types of user activities differ in their ability to inform such expertise models. And in the last part, we try to anticipate users' communication behavior on social media applications. So we will look into factors that are correlated with users' reply behavior on these applications, and we will compare whether these factors differ across different community forums or whether they are stable. So the idea is, in the first two parts, we are mainly looking into observational data, into data which we can observe by looking into these conversations going on social media applications, and we somehow try to make sense out of that. While in the last part, the last part can be seen as the first attempt to try to understand why we observe what we observe, because here we really start looking into the factors that potentially impact users' behavior on these platforms. Okay, so let's start by looking into how one can learn distributional semantics from public conversations on social media applications. So our first objective here is to learn some semantically cohesive stacks of words which represent our topics or our concepts, and then to relate messages with these concepts. So what we actually want to know is what is this message about? We want to know that the message is mainly about a political topic and probably as well a bit about the health topic. And one can do that by using state-of-the-art methods, text mining methods, which allow us to do exactly that. I will explain that then on the next slide. But going beyond that, what we were interested in is looking whether the social context of a message helps acquiring better semantic models. So, as a method for learning the semantically cohesive stacks of words and the topic annotations of messages, we use in our work mainly topic models, which is a set of algorithms which allows us to do exactly that. So by using these algorithms, we can exactly learn that. We learn the semantically cohesive stacks of words from the data we observe, and we learn these topic annotations per message. And the most basic topic modeling algorithm, which maybe some of you know, is latent degree allocation, which was introduced by Bly and others in 2003. And this algorithm basically defines the joint probability distributions of observed and hidden variables, and it defines some dependencies between these variables. And from this joint probability distribution, one can then get a conditional probability distribution of the observed variables, of the hidden variables given the observed ones, and this allows us then to approximate these two hidden variables which we want to learn. So LDA was developed in 2003, and it was developed for general collections of documents, and therefore it obviously does not take the social context of documents into account. For social media documents, such as tweets or blog posts, we have this additional social information. So we have information about the usage of documents, so we know who authored the document, who replied to it, who liked it, who read it, who navigated it. And we also have information about the behavior of the authors. So we might know, for example, what are the people the author is communicating with most frequently, or what are the forums he's posting to most frequently, and things like that. And we got especially interested in the question whether this information helps us to learn better semantic models from social media communication. And to answer this question, we first needed to find a way to incorporate this additional information into the statistical learning process. And luckily in 2008, Andrew McCullum and David Minno developed a topic model which allows us to do exactly that, namely the Dirichlet multinomial regression topic model. And this topic model allows us to incorporate arbitrary types of features. So this X here is the feature vector basically, and this model then assumes that every document was generated from a feature-specific topic distribution rather than from a general topic distribution. And this means nothing else than that documents which show similar feature distributions tend to be about similar topics. So if we would, for example, include the information about who authored the document, then that would mean that documents authored by the same person are more likely to be about the same topic. So our aim here was to explore whether different types of pragmatic and behavioral metadata help to learn better semantic models from users' communication. And to approach this question, we use this DMR topic model, and we basically incorporated different types of metadata into this model and compared then different models in terms of their predictive performance. For measuring the predictive performance, we use perplexity, which is a standard measure used by the topic modeling community, and it measures nothing else than the probability of words in future documents given the model we have learned. So the assumption here is that a better model is better able in explaining words of future documents. So in the experiment, we used the data set from Boards.ie, which is the most popular message forum in Ireland. And it's a typical message forum where people have a bit more than 700 forums about all kinds of topics like movies, video games, and so on. And as a training data set, we used all posts which were published within the first week of February 2006. And as a second training data set, we used all posts which were published within the last week of February 2006. And as a test data set, we had two separate test data sets in this experiment. We used 3 future posts of each user who showed up in our training data set. Because as I said, the idea of the evaluation was that a better model is better able in explaining future content. So we needed some future content to test this hypothesis. So what we did is we had these 8 different topic models, which in part didn't incorporate any types of metadata, and others incorporated different types of behavioral and pragmatic metadata. And we wanted to compare these 8 models in terms of their predictive performance. And what we then basically did is, on this figure, you can see here on the y-axis, you see the perplexity. And the lower the perplexity, the better the model. That's the idea, the better the predictive performance of the model. And on the x-axis, you see the percentage of training documents used during training. And the idea is, the lower the perplexity, the better the model, and the less training required, the better the model. So one can see here on this graph, basically the red and the black line are the baseline models, so that's LDA. And the more we train the model, the better the predictions become. So that's the thing which one knew actually before. And on this slide, there are 2 things interesting. The first thing are the 3 lines here on the top. These are the models which incorporate pragmatic metadata on a post level. So these models incorporate the information about who authored the post or who replied to the post. And one can see that these models become worse the more we train them. So that's the typical overfitting effect, actually, which one can observe. So why does this happen? That basically happens because the statistical assumption of the model becomes too strict, because this model basically assumes that future posts of a user will be about the same topics as posts he authored in the past or posts to which he replied in the past. And that's a very strict assumption, and that's why these models don't perform good. The other interesting thing are the 2 lines here on the bottom, and these are the models which show lower perplexity than LDA. And these models basically incorporate information about the top communication partners of users. So these models assume that a future post of a user will be about the same topics as posts which were authored by similar users, and similar users are the users with whom a user is communicating most. And that makes intuitively sense, and that is what we have also seen in this experiment. So what we observed from this little experiment is that posts are more likely to be about the same topics if they are authored by users who tend to communicate with similar users, and that the topics of users' communication partners seem to be predictive for the topics users will talk about next. So behavioral metadata can apparently indeed improve semantic models, since users who share similar communication behavior are also likely to talk about similar topics. But pragmatic metadata, as we have seen, leads often to statistical assumptions which are too strict, and therefore we observe this overfitting effect. So what we have seen from this first part is basically that we can use existing state-of-the-art text mining methods such as topic models to already learn lightweight semantic structures from public conversation, and that indeed the incorporation of social factors makes a difference. It can have a positive impact, but it can also have a negative impact. And what we have learned from that is actually just that one needs to understand what one incorporates and what then the statistical assumption of the model, so to see whether this makes sense or not.
Did you also look at the combination of different predictors? So you said that similar users tend to talk about similar topics, but similar topics don't necessarily lead to future similarity, right?
Yeah.
What about similar users talking about similar topics? So the combination of the two.
I mean, we combined the author information and the communication partner's information. So we combined the who authored something with who replied something, but I'm not sure if that was your question.
Yeah, but the combination of like, so similar users tend to talk about similar topics. That was like the predictor, right? So if we are similar users, then the likelihood of us talking about a similar topic increases in the future.
Mm-hmm. We measure similarity by connections, by communication connections, not by topics.
Okay, but you also, like, you had the model that got worse.
Yeah.
Because it was too strict. And that was the model about similar topics, right?
About similar, no, it was just about posts you authored or you replied to, but no similarity.
Okay, then I got it wrong. Sorry,
yeah. Yeah, so besides learning the semantic structures, I mean, one often also wants to learn relations between users and the semantic structures, because what one is often interested in is how much does the person knows about the topic, or how much is the person interested in the topic. So that's why we also did an experiment on learning expertise profiles of users by observing their activities. And for this experiment, we actually used Twitter. So what we aimed to figure out was what are the topics a Twitter user knows about, and which user activities and related outcomes may reveal this information. And what we did in the first step is we looked at the Twitter interface to figure out, okay, what are the potential sources of information which we can use for this experiment. And there are obviously like information like tweets and retweets authored by a person, and there's also like bio information user may provide, and there's also information about list memberships of users. So on Twitter, user can create user lists, so they label these lists, they can add a short description about the list, and then they basically assign their contacts to the list. So the idea behind user lists is that you organize your contacts somehow. So I might, for example, create a list which I call like a research mates or semantic web researcher or whatever, and then I put my contacts into that list, and then this list membership shows up at the page of these people. So these were the 4 types of information we identified at the beginning, and we thought, okay, these types of information may reveal something about the expertise of people. And what we did in the first step is we wanted to figure out how useful are these different types of information for humans to judge the expertise of other people. And to approach this question, we conducted a small user study where we had 16 participants, and we gave them a task where they had to rate the expertise level of selected Twitter users with high and low expertise of the topic semantic web. And we didn't show them the Twitter interface, so we didn't show them like the Twitter pages of the users, because we didn't want them to see like the username or the user picture or things like that, because it would obviously influence their judgment. So what we did is we just showed them the plain textual information in form of simple tables within this experiment, and we showed them this information under 3 conditions. So under condition 1, we showed them all 4 types of information in randomly ordered columns. In condition 2, we only showed them tweets and retweets information, and in condition 3, we only showed them what we call contextual information, namely list memberships and bio information. And at the end, we always ask them, like, how much do you think this person knows about the topic semantic web? And we had 4 replicates, so we had 4 Twitter pages for every condition and every expertise level, so every subject had to rate these 24 Twitter users in sequence. And after having done this human data collection, we conducted a 2-way ANOVA analysis with Twitter users' expertise and the 3 conditions as between subject variables. And interestingly, there was a significant interaction between the conditions and Twitter users' expertise. So our post-hoc test showed that users' ability to correctly judge expertise of Twitter users indeed differs significantly between condition 1 and 2 and condition 2 and 3. And one can see that also from the plot here at the side, because the slope of the line indicates the ability of our subjects to correctly differentiate between experts and novices. And the red line shows the performance of subjects when they saw all 4 types of information. So obviously they performed best when we gave them all information. When we just gave them tweets and retweets, then we were actually not really able to differentiate between low and high experts. That's the green line. So you can see they really performed very bad. And when they just got contextual information, they were still quite good in making their judgment. So from this little user study, we have seen that for humans it makes a difference which types of user-related information we give them to inform their judgment. But actually, we were more interested in if it makes a difference for computational expertise models, because our goal was to learn computational expertise models of users. So to approach this question, we did another experiment where we basically first selected 10 topics, which were semantic web, biking, wine, Democrats, Republican, medicine, surfing, dog nutrition, and diabetes. And for these 10 topics, also we follow directories exist. And we follow is an application where people basically can register themselves at a maximum of 3 topical directories. And then we follow implement an algorithm which ranks users amongst others by the number of users who are following them in a certain directory. And I'm, for example, registered, I think, for semantic web, social web, and I don't know what else, I think arts or Austria, something like that. But the intuition was that people might register themselves for a topic they might have expertise in. And there was actually previous research done on exploring that. So people did user studies and showed that the top people in a follow directory are indeed perceived as experts for this topic. So that's why we decided to use that as a proxy ground truth for our experiment. And we crawled the top 150 users for the corresponding follow directory. And we only used users who appeared in one of these directories, who mainly tweeted in English and who didn't protect the information, so that we were able to get these 4 types of information from them. So we ended up having a bit more than 1,000 users, for which we now had the activities, the related outcomes, and we also had at least one ground truth label for which we knew, okay, it's likely that they are perceived as experts for this topic. And what we did then, we again fitted an LDA model to this communication data set to have these semantically cohesive stacks of words which represent our topics or concepts. And in the next step, we inferred for each user 4 different topic distributions. And we did that by using the 4 different types of information we have available. Because we were interested in 2 things. The first thing was how different are these topic distributions? And the second question, actually the more important question, how well do they reflect the perceived expertise of users? So what we did first is we compared the different topic distributions, how similar are they on average, and we did that by using the Jensen-Chandler version. And one can see from this figure that interestingly retweet and bio information is extremely similar. So the topic distributions which we inferred from bio, tweet, and retweet information tend to be very similar. And this suggests that people tend to tweet and retweet about similar topics, and that they also tend to mention topics in their bio which are similar to what they tweet and retweet about. I mean, I probably should mention that when I say what they mention in their bio, I mean, we obviously also resolve links. So people often just put a link in their bio, and then we of course got the information from the website to get a bigger picture of what their bio is about. Interesting is also that list information seems to be most distinct from bio, tweet, and retweet information, and this suggests that people put other people into lists about topics which apparently have nothing or have few to do with the topics they tweet, retweet about, or they mention in the bio. So one potential explanation for that is that people put people into other lists because of things they know about people from real life. So I might put my workmate into a list called Semantic Web Researchers, although this person does not tweet about any research-related things. So that's why we thought, okay, lists seem to be interesting, at least because they are somehow different. But as I said, we were interested in exploring to what extent these topic annotations reflect the perceived expertise of users. And to explore this question, we set up a classification task. So what we did is, the aim of the classification task was to classify users into their correct follow directory. And to train the classifier, we used these 4 distinct topic annotations. And the idea was that a classifier trained with topic annotations which are good in reflecting the perceived expertise should perform better in then assigning the users to the right directory from which they came. So we trained a partially square classifier with these different types of information and performed the fivefold cross-validation and used the F1 score, which is the harmonic mean of precision and recall, to compare the classifier's performance. So what one can see here from our results is that across all 10 directories, actually list-based topic annotations perform best. So that means a classifier trained with topic annotations inferred from users' list memberships perform best, led to the highest F1 score, and it suggests that list-based topic annotations best reflect the perceived expertise. I mean, we also repeated the experiments with different numbers of topics, because obviously also the number of topics which one learns, I mean, how fine-grained topics are might influence our results. So we then repeated the experiment with varying the number of topics from 10 to 700, but one can see that this actually doesn't make a big difference. List-based topic annotations always perform best. Okay, so from that, we have seen that, I mean, again, we were just using existing methods like topic models, and one can already learn these semantic user profiles by observing the activities, but apparently different types of activities indeed differ in the ability to inform users' expertise judgments and also to inform the creation of expertise models. So yeah, so in the last part, we were looking into anticipating users' communication behavior by observing their communication activities on a message board. And we used again a data set from Boards IA, that's the Irish message board, for conducting this experiment. And we were basically interested in two questions, mainly in the question about which factors are correlated with the start of discussions, so what factors might potentially impact users' reply behavior. And the second question was whether these factors are stable across different community forums. So we wanted to know whether we can observe like global patterns, or whether these patterns are more local and depend on the community which we currently study. So for the experiment, we randomly selected 10 forums out of the 725 forums, and we again only used posts published within 2006, since the data set we had was for the year 2006. As a first step, I mean, we wanted to explore factors which potentially impact users' reply behavior. So we first had to come up with some factors. And what we did here was we created 5 different feature groups which were supposed to reflect the factors we are interested in. So we had user factors, content factors, title factors, focus and community factors. And the idea here was that if, for example, in a certain forum, user features are most important to predict which posts will get replied, then in this forum, apparently it's more important who says something than what is said in order to predict which post will get replied. On the other hand, if content features would be most important, then that would indicate that only posts which show certain content characteristics are likely to get replied. If title features would be most important, then that would suggest that in a certain forum, maybe only posts which have a catchy title or which have question marks in the title are likely to stimulate discussions. And if focus features would be most important, then that could mean that only users who show a certain topical focus, that mean who are specialized in certain topics, are likely to stimulate discussions. And community features basically describe the relation between authors, posts, and the community. So here the intuition was that maybe for certain community forums it's important that a post really fits into the interests of the community or fits into the topics of the community in order to start discussions or to stimulate discussions. So what we did here, we set up again a classification task to explore this question. So we had a binary classification task where we wanted to differentiate between posts which got replies and posts which haven't got replies. And we used all thread starter posts which were published within 1 year, namely 2006. We trained a linguistic regression classifier with these 5 different feature groups. So we trained it with each feature group in isolation and also with a combination of all feature groups. And we again compared the performance of different classifiers by using the area under the REF curve as a ranking criterion. We also inspected the coefficients of the logistic regression models in order to gain some insights into which features have a positive or a negative impact on the post getting reply. So what we observed from this experiment is that the factors which are correlated with users' reply behavior are indeed different for different community forums. As I said, we randomly selected 10 different community forums, and we were somehow expecting that there are stable patterns. But apparently, it's really, there are some stable patterns, but not for all of them. So apparently, really, the factors are different. And we had, for example, some forums in which only posts got replies which showed certain certain content characteristics. In other forums, it was more important who said something rather than what was said, as I said before. And we also had forums where it was important that the users are really specialized on certain topics, so that they have a topical focus. And on the contrary, in other forums, the contrary was actually the case. The users had to be not focused at all, so they had to be novices in order to stimulate discussions. So we had like one forum which was about the Trinity College, which was a nice example for that. So the less experienced user had, the more novices they were, the more replies they got, because people are obviously seeking help and other people feel like helping them if they are completely new to the area. So what we saw from this experiment is that apparently the purpose and the nature of the community seems indeed to impact users' reply behavior, and that the community subject and its specificity also seems to play a role. To give you an example, these were the 10 forums we were looking at, and for example, the forum mobile phones or motors were examples where content features were most important. So obviously a classifier trained with these content features outperformed classifiers trained with other feature groups in isolation, and also a classifier trained with a combination of all feature groups. On the other hand, the community cuckoo's nest was an example for user features being most important, because it's a community where people are basically allowed to talk about everything. It's just that they share a common mindset, more or less. So in this forum, it's useful to use just user features in order to achieve the best performance. So from this last experiment, we have seen that for anticipating users' communication behavior, it seems to play a role to understand in which context one is studying that, because different communities the reply behavior of users in different community forums seems to be impacted by different features. At the beginning of my talk, I said that machines, or for making information on the web, machine interpretable semantics are required. And I said as well that answering these questions like what is this message about and what might we need to know about is easy for humans, but for machines it's difficult unless we give them the right semantic background knowledge and the right semantic structures in order to be able to interpret the meaning of the textual information. And in my talk today, I have showed you that existing methods like topic models are already really powerful and can be used to acquire lightweight semantic structures from public conversations on social media applications. But when one applies these existing methods to social media documents, there are certain things which we need to take into account. For example, user behavior and pragmatics can be exploited to improve emerging semantic structures. So that is something people should take into account, and probably also existing methods could be improved by going beyond just analyzing the textual information, but also taking the social context into account. Another thing which is important is that not all user activities are equal. Different types of user activities and related outcomes differ in the ability to inform such automated methods and models. And the final thing is that also equal types of activities, as we have seen, because we just studied the reply behavior actually, can be distinct on different platforms, since they might be impacted by different factors depending on the platform and the context and the community we are studying. So we believe actually that understanding the different types of user activities on a platform and the factors which drive them is important in order to acquire semantics from the activities and the related outcomes. So there are a couple of future challenges and opportunities for future research, and in our work we actually only studied the relations between semantics and user behavior on a very concrete level, on a feature level actually. So we haven't done any work on theories, right? But it would be extremely interesting to also start thinking about that, because there are semantic theories out there which try to explain the meaning of a word. And for example, speech act theory suggests that the meaning of a word depends on the speaker, on the listener, and on the situation. And then there are the social theories. And social theories are good in explaining the behavior of users, of individuals or groups of users. So somehow there seems to be a relation, because social theories might have the potential to explain how the social context of a word is created. And semantic theories, or in part semantic theories, suggest that the social context of a word is important to explain the meaning of a word. So I think that could be a really interesting area to do future work on, and that could also have implications for text mining or knowledge acquisition methods, because these methods are actually relying on very simple semantic theories like this distributional hypothesis, which just says that the meaning of a word is defined by its context. So it's just co-occurrence-based methods. I mean, they work pretty well, but still I think there is some potential for future work. And besides that, I also think that the evaluation of semantic structures and the semantic preciseness is a big issue. I mean, you might have noticed that in our work we were always using like task-based evaluation. So we are always using this classification task or some help tasks in order to evaluate then the quality of semantic models. But it would of course be interesting to explore whether semantic structures really reflect the conceptualization of users, because that's what they are made for, and that's their purpose. And all other kinds of evaluations are just things which we usually do to get things done, but it's not that what we really want to evaluate. So I think that would be another area for future research. Yeah, and that's everything from my side. So I'm happy to take your questions.
Thanks. Last questions. I do. To what extent do you intend to take more cultural or language factors into account? Because I can imagine that non-native speakers tweeting in English will have a harder time generating meaning from tweets, and different cultures have attached different meanings to different words. So how do you take that factor into account?
Yeah, that's a good question. I mean, you're definitely right. I mean, that's a big issue. We are just looking into the English-speaking social media population, which is obviously not representative for the whole population. And there are recent work has been done actually by people at Park, the group I was joining during summer, which studied language differences in Twitter, and they actually addressed this problem. But I mean, in my work, I'm not really looking into language difference. So I think that's another aspect, but that's probably a separate problem. You know, I mean, the English speaking, studying this English speaking communities already. I think going into these cultural differences and language differences is extremely interesting, but it's, from my point of view, already a separate research problem.
You're right. I was wondering, so just in my Twitter, I found that it's really simple, naive approaches to are very effective. Because as soon as someone mentions the word, say, semantic web, they all of a sudden become semantic web experts to a certain extent. I mean, the chance of them being that knowledge is much higher. Did you look at your classification before based on that? The topic model, or really, sort of simple, just sort of obvious. If they mention it, just interpret it.
I mean, we tried different classifiers for the, but we were always using topic annotation. I think your question is more like if we used just the keyword-based approach.
Yeah, I've just found that those are surprisingly powerful.
Yeah. No, I mean, we didn't compare that with keyword-based approach, because the idea was to, we wanted actually to learn the models, right? So it was just, the task was more a way to evaluate the model. So we didn't want to have just feature lists which have no meaning. You know what I mean? We wanted to have these semantically cohesive stacks of words, and in the best case, I mean, we actually plan to also evaluate the semantic cohesiveness of the topics, because that would be something we are interested in. We want to know how good are the semantic structures we learn, and if we would use, I mean, I agree. I mean, there are actually also studies out there which compared, I think it was the performance of TF-RDF or something with topic models as features. So one were using like, I think just TF-RDF, and the other were using like topic models, and it turned out that TF-RDF is actually better for doing classification because it just uses the most discriminated words, and topic models are not doing that. I mean, the purpose of a topic model is not to be the best feature for the classification task. It was just for us a way to compare different topic models. Yeah.
So let me ask you, sorry.
This is interesting.
Yeah. So the purpose of this is really interesting stuff. The purpose of the topic model is to have some sort of understanding of how, I guess, people tweet, how people's expertise, right? This is a topic model people's expertise. But the way LDA is set up, correct me if I'm wrong, it's really hard for humans to have any idea what's going on. We can look at the most predictive words in each topic.
Yeah. But
in terms of actually getting into it, it's more difficult than that. Do you have any thoughts in terms of how you're going to move the organization?
Yeah, I mean, like if you represent it in text cloud, then it's kind of human readable. I think more the problem is that it's often noisy. I mean, it's difficult really to get very semantically cohesive stacks of words. But from terms of, human interpretable, I would say like, backs of words with weights are what people are, or what social media users are kind of used to, right? I mean, you see these text clouds everywhere. So I would not say that it's not possible for humans to interpret that.
But it's not like you don't get topics like computer science or.
No, but I mean, there is also work on labeling. Then that would be a next step. Like you learn the topics and then you learn the labels. It's just an additional machine learning step to come up with that.
Okay.
I wonder if there's ways to leverage the fact that people engage in multiple social media to either improve these models or develop different to deal with just return more social friendly. So I know that the reason I thought of it, the one example you had was Barry Wellman. He was retweeting the top outlets and all this, and your little screen captures. And we know that Barry Wellman, you could look on his website and you would see that he's an expert on social networks. He also posts this on it prolifically. He also has a Facebook page, and I wonder to what extent would it be possible to start tracking those things? I know a lot of communication research does what you did, where you look at sort of one medium, but obviously you can get information about expertise sort of present in multiple arenas.
Yeah, that would be extremely interesting. But then you run into another problem, which is in the identity reference problem, right? So yeah, I'm not sure. I guess if one would have a good directory where you have like verified information, then that would make sense to try that out. But otherwise, I'm just a bit worried about if you add to one problem another problem, then in the end it's either don't know why it's not working, or you don't know why it's working, because it can be somehow, and the more parameters you add into the model, the less, but the more complex it becomes. But yeah, definitely with interest. We did a bit of that but we just resolved links, as I said. So we were just using this additional information to get a bit of, a bit more information about people, because actually lots of people don't put any words in their bio, but just put a link to their work site or whatever. So this information turned out to be really useful, actually.
Yeah, so I like when you brought up in your future direction the notion of kind of speech something, and it strikes me that some of the stuff that you were capturing in the early models are basically the way the computational system has been built, or the way Twitter's been built, is they are essentially capturing dialogue acts, right? So they're getting kind of reply structures. Mm-hmm. And so I'm curious how much of that you think is coming just from the fact that particular dialogue act or that information that you're getting is then instantiated in the system, versus being able to model some of that within the given context. So you could take discourse markers and things like that to try to understand response pairs and transitions and things like that, and adding that layer of information into it. So I think some of the boost that you get in the early parts is in part helped out by the fact that the way the system has been built just does something that's very natural in conversation, right? The closer we are in time, the more likely it is I've asked you a question and you've responded to things like that. Now on Twitter we have sort of a reply, you have ways to sort of make that explicit reply to, which seems like the features you're picking up on. But you could also pick up some of those features by doing kind of more detailed analysis of the content and looking for discourse markers or dialogue app markers that kind of exist within the content. So is that kind of the direction that you're thinking about to get more at the pragmatics?
Yeah, definitely. I mean, I think we started with the simplest feature we could think of, and we just, incorporated like the top communication partners per user, which already turned out to be good. So it was a very simple feature, but I mean, looking more detail into the communication structure would, I assume that would be helpful, definitely. It was just a starting point of seeing, because the intuition was just behind that, as you said, like, if you talk to someone, I mean, I don't pick randomly a topic, about which I will talk with you, right? So if we meet, I mean, at some point people agree on a certain set of topics they're both interested in, and then they talk about that, and it's not a random process behind the topic.
Right? Yeah, for some period of time it's coupled, but then there's a decay of that as well too, right? So as you move further and further in time, less and less likely that we're talking about the same topic. Yeah. And so trying to understand what that decay process is, and or when there's sort of major conversational shifts that are occurring, are things that you might be able to pick up by doing more than just kind of keyword examination of the content, but trying to look for those dialogue app. Oftentimes they get thrown out as stop words, but I think they actually have some utility as well too, if you can kind of understand them in a given context.
Anything else? More questions? I guess that's it then. Do one round.